Welcome back to The Explainer. Today, we're taking a fascinating journey into the architecture of one of the most incredible tools out there for bridging the physical and digital worlds. We're going to completely demystify Azure Digital Twins. We'll break down exactly how you map a physical space, how you connect your real-time devices, and how data actually flows through this architecture to give you actionable insights. Okay, let's dive into this.
Here's our roadmap. We are going to logically trace the life cycle of just a single data point. We'll start with modeling the environment in Phase 1, then we'll bring in live data in Phase 2, process it in Phase 3, and finally, turn all of that into powerful analytics in Phase 4.
Section 1. The Blueprint. Modeling your business environment. This is where we introduce the concept of creating a live, up-to-date digital representation of entire physical spaces. We're talking things like sprawling factories, massive stadiums, or literally entire cities.
So before you can track what's happening in your business, you've got to build that live, up-to-date digital representation of it, right? Well, Azure Digital Twins is the platform as a service, or PaaS offering, that actually makes this whole thing possible. It lets you create these incredibly detailed twin graphs based on digital models of your entire environment. So we're not just talking about a flat list of assets here. It's a dynamic, connected graph that models how every person, place, and thing actually relates to one another.
But it turns out to actually write out this model and describe your business environment to the cloud, you need a specialized vocabulary. And that's exactly where DTDL comes in, the Digital Twins Definition Language. It's basically a JSON-like language used to tell Azure exactly what entities exist in your space, what their state properties are, and perhaps most importantly, how they all relate to each other.
Let's anchor this with a concrete example. Imagine you're building a smart building solution. You wouldn't just want some generic device model, right? Using DTDL, you'd define a specific building type, a floor type, and an elevator type. Then you use those blueprints to create your actual digital twins, like say, Building 1, Floor 5, Elevator B. And because you define those relationships in DTDL, you can connect them all together. You literally form a conceptual graph that says Elevator B is located on Floor 5, which is inside Building 1.
And the really great thing about learning this specialized vocabulary is that it completely scales. DTDL version 2 is actually fully compatible with other Azure IoT services, including IoT Plug and Play. So, by defining your environment this way from the get-go, you're seamlessly paving the way to connect your entire solution with the much broader Azure ecosystem down the line.
Section 2. The Ingress. Connecting IoT and devices. Now that our environment is modeled, we need a way to actually feed it.
So our blueprint is modeled in the cloud, and it looks great, but it's totally static. We need a bridge to bring in live, real-world data, which leads us to the million-dollar question for literally any IoT solution. How do we keep our twin properties perfectly synced with physical reality? Because let's face it, a blueprint is totally useless if it doesn't reflect reality in real time.
The primary answer to that is Azure IoT Hub. It connects your solution to your IoT and IoT edge devices, and that's what ingests the live telemetry driving your models. Now, what's really interesting here is that these hub-managed devices aren't just blindly sending data to the twin. They're actually represented as part of your twin graph themselves. And you've got flexibility. You can either spin up a brand new IoT hub for this, or just connect an existing one you already have running.
But, you aren't strictly limited to physical sensors. A true digital twin often requires real business context. You can also use REST APIs, connectors to other Azure services, and even logic apps to pull in valuable data from your existing business systems, stuff like an ERP or a maintenance database. This lets you incorporate all that crucial context directly into your twin graph.
Section 3. The Brain. Processing with Azure Functions. This is where data actually becomes meaningful.
So, data is flowing in from sensors, but raw data really isn't enough. It has to be interpreted. Let's jump back to our smart building example. Let's say IoT Hub receives a telemetry spike from a vibration sensor. But how does the overarching twin graph actually know that this specific data point means, hey, elevator B is currently moving?
Well, it knows because of a super rich event system and customized business logic. Azure Functions act as external compute resources that basically just sit and listen for these events. So the crucial point is that Azure Digital Twins doesn't automatically interpret the meaning of a sensor spike out of the box. Instead, you write an Azure function with your own custom business logic to intercept that telemetry, evaluate it, and then explicitly update the property on the digital twin to say, status moving.
Let's explicitly map out this technical flow step by step, because this is absolutely the core engine of the architecture.
Step 1. Your IoT edge devices out there in the physical world are generating live data streams. Step 2. IoT Hub ingests that data and handles all the device management and security. And then Step 3. Azure functions act as the brain. They process those raw events according to your custom logic and issue the exact commands to update your live cloud twin graph. This right here is your chronological flow of data from physical hardware to the cloud graph.
Section 4. The output, analytics, and downstream insights. Let's talk about the final stage of the funnel, what we actually do with this processed data to drive better products and reduce costs. All right, we've modeled the environment, we've ingested the data, and we've processed it. Our twin graph is humming along nicely as the live central source of truth. But where does all this valuable, contextualized twin data actually go after it's processed? You've got to route these events downstream to other services.
Luckily, you can create custom event routes to export this data to a whole variety of really powerful downstream services for long-term storage and complex analysis. You can use Event Hubs, Event Grid, or Service Bus to send data through custom flows. You can automatically push store-sized updates to Azure Data Explorer, which is great for tracking how your twin changes over time. You can even dump massive amounts of data into Azure Data Lake for cold storage, or run heavy data analytics using Azure Synapse Analytics. Basically, the egress is incredibly flexible.
But interestingly, let's move to and see how this builds. Before you even export your data for long-term storage, you can interact with it right now. Azure Digital Twins features a very powerful query API. This allows you to extract real-time insights directly from the live execution environment. You can search across properties and relationships to answer really complex questions right in the moment.
Let's be honest though, for most subject matter experts, staring at APIs and JSON code isn't exactly the best way to understand a factory floor. And that is exactly why Azure offers the 3D Scene Studio. Using a low-code builder, you can map visual 3D elements directly to the digital twins in your graph. So, if a machine overheats, it visually flashes red right there in your immersive 3D model. Pretty cool, right?
And this brilliantly illustrates the big picture of how data is consumed at the absolute end of its journey. Depending on your specific consumption need, you just choose the right tool. Need visual context? You use 3D Scene Studio to map those elements. Need analytical history to track the past? You query Azure Data Explorer. Or maybe you need to trigger a workflow action, like automatically dispatching a repair technician. For that, you integrate with Logic Apps. The Twin Graph really is the hub, and these services are all the spokes.
We've traced the incredible journey of data, starting from a physical sensor, moving through the IoT Hub, being processed by Azure Functions, mapped right onto a live digital twin graph, and finally routed out to advanced analytics and immersive 3D visuals. The architecture is all built and waiting for you. So I'll leave you with this provocative thought. What physical asset will you digitize first to track the past and predict the future? Thanks for joining me on The Explainer, and keep learning.